What yesterday something we have done, that a little bit we are going to revise that one also. The first point is there, the position of hydrogen in the periodic table, that I explained to you, that how the position of the hydrogen in periodic table is little ambiguous. Okay, why it is ambiguous? Because it is showing the
Position of
similar.
hydrogen is not.
Yeah, it shows the no properties with the some other element also. What are the group 17 element? Here, if you want to read the some lines, you can also read the some line here. See, hydrogen. 1 second. This they are saying hydrogen in the first element in the periodic table. However, it places position in the periodic table has been a subject of discussion in the past. As you know by now that the element in the periodic table are arranged according to their electronic configuration, that is okay. If they if you are going according to electronic configuration, up to that portion is okay. But when you are going to study some other aspect of the properties aspect, so you will find that is they are having the some differences are also there. Let us see the differences, where the differences they are saying. So hydrogen has the electronic configuration 1s1 and 1 electron. Oh, why this is? Wait, no, I don't know. It's coming.
Sir, they are saying the same thing only that you told yesterday, that it has electronic configuration similar to the alkali metals and first group, and their properties are similar to the 17 group.
Okay, so that is the same what we study the same, na? Yes or no?
Yes.
Okay, so that one we are not going. We are going to study some the important point which we have to see this one. Hydrogen, that also we have covered. See, the some datas are there. That datas we have to study also. What are the datas are there? This one, see. Total the here you see this one. What they are saying? Occurrence, if you see dihydrogen H2. Dihydrogen is the most abundant element in the universe. How much? 70% of the total mass of the universe is the principal element of the hydrogen. That you need to know. Okay. 70% total, 70% is the hydrogen itself only. Where they are there, that the data you need to understand, that is the here they are saying 15.4% is there in the earth crust. Okay. It is also in the sun also is there. Here they are saying light nature is much less abundant, 0.15% Mars. In the earth atmosphere, it is also there. So that you try to understand. Isotope we have covered. Next one, what we are having. Lifetime of the this one. See, yesterday something mistaken was there. Here they are saying of these isotopes, only tritium is radioactive and emits low energy beta particles. Half-life is there 12.33 years, not 12.33 years. Half-life means if suppose 1 gram is there, we are having half 1 gram. So it will become that is 1 by 2 gram. In how many years it is going to decompose? In 12.33 years. So you must be knowing that, you keep in mind that is this type of problem they ask. Okay. Next one. Let us try to see. Some characteristics are there. Hydrogen is having some characteristics. Okay. What are the characteristics are there? Here you can find out. So first point, see, percentage abundant, you see, percentage abundant. So hydrogen, deuterium, hydrogen is 99.9%. Okay. 99.9% means that is the almost 100% is there. Deuterium is, see, is 2 less percent. And tritium is 10 power minus 5 times. It means almost negligible. Okay. 10 power minus 15 is the radii of what, Stanoy? Radii of what? Radii of 10. That is 10 power minus 15 picometer. What is the size? Which size is there? 10 power minus 15 picometer. Any idea?
Sir, that electron orbital.
Nucleus of atom. Nucleus of atom is how much? 10 power minus 15 picometer. The radii of nucleus is 10 power minus 15. And radii of atom, if you talk about atom, It is what is the size of atom, you can say. Size of atom, how much is there? 10 power minus 10 picometer. So they are the very, very smaller one. That is what little bit I asked. Now the second point, relative atomic mass, you go with the relative atomic mass. It is having the 1 gram. This is the 2 gram and this is the 3 gram. That is why its formula become 1H1. This is the 1H2 and this become the 1H3. Now the next one, melting point, you see, melting point, it increases. Why? The question is, Sanoy, why the melting point increases? Melting and boiling point, why increases? That you explain. What the factor is
Sir,
responsible?
you told.
What?
Sir, you told me already some nuclear now. That I'm right.
It's not audible what you are saying. Too much sound is coming.
Sir, now audible.
Just audible only, but too much no noise is coming. Just I want to know what factor must be responsible in the increase of melting point from the hydrogen to tritium. That I am asking. Which concept is responsible?
Sir, higher intermolecular force between them.
Why
Between
the
protons and electrons.
region higher intermolecular force? That is correct. Why higher intermolecular force are there? Why it is increasing from hydrogen to tritium? Why? It is increasing. Why it is increasing? Yes or no? Why it is increasing? Intermolecular forces are why it is increasing. See, whatever the intermolecular forces are there, Sanoy, okay, they are the what is proportional to what proportional, Sanoy? They are the proportional to, if you talk about, to van der Waals force. I am writing van der Waals force, VW, van der Waals force, proportional to molecular mass. Okay, molecular mass or size. Now, so molecular mass or atomic mass increases. So van der Waals force of attraction also increases. Yes or no? Hello. So no.
Yes, sir, I'm writing that one. Molecular mass and size.
So that one is there. Van der Waals force of attraction proportional to molecular mass or the size. So here you see mass is 13.96 gram. No, it's there. Mass is here. What is the 1? This is the 2 and this is the 3. So atomic mass increases.
Sir, I saw you have just sent something. Should I check it now or should I check it later?
Which one?
Sir, I saw you have sent a photos in my WhatsApp. So that is on top.
I didn't send any photos to you. Somebody else might have. No. Don't see. No. Oh, by mistake it's gone. Not by mistake. Actually, it was not getting on. That is why I shared. Okay. So this melting point and boiling point is clear now?
Yes.
Okay. Now the density. You see the density. Obviously, if it is mass is less, so its density will also be less. 0.09, 0.18, 0.27. Okay. Next one, enthalpy of fusion. Enthalpy, it is radioactive, so we are not going to study other properties. It is radioactive. Why? Because it is emitting the harmful rays. Since it is emitting the harmful rays, so its study is not there that much. Okay. We don't study the radioactive substances because they are the harmful. Enthalpy of fusion, it is there, the less is there, hydrogen 0.117 and here is 1.7. Vaporization also you can see these are the, here enthalpy of bond dissociation, this is quite important that you need to know, 435.8 kilojoule and here is 443. So deuterium is quite, because of it is the more is there. Intermolecular distance, here that is almost they are having the same. Ionization enthalpy, we don't have to study there. Here is the how much is there. Quite high is there. Very not quite high. It is compared to other element. It is very high. 1312.
I have one question. So why the other values are not for that deuterium?
They did not study. I don't know that the exact fact. Okay, ionization energy for this one, because either what to say. Here, this is the radioactive that was I know. Here we need to find out why it is not there. Hydrogen, deuterium. Okay, maybe its study is not required for this one. It may not be required. That is why they didn't perform the experiment, so that they didn't give. That may be the reason. Or the ionization energy may not be existing. That something may be the reason. I'll find out and I will tell you. Okay. Here, here you see it is very high. Okay. If you see the S block element, right? S block element. See, I am giving you. Give me time. Ionization enthalpy of IONIS. Wait. Ionization enthalpy. Yes. Is it visible what I am typing on the board? Here is no.
Sir, I told visible.
Okay, thank you. Okay, see the value of the ionization enthalpy. You see the S block element. Actually, I am supposed to see here. Is there this one? Yeah, this is. So now kindly see this one. What the values you are going to get here? What the value are you getting? See, this is the lithium is how much is there in the kilojoule per mole only. You see the 519. Yes or no? 519.
Yes,
Is it visible? Then it is sodium is 494, 418, 402, 376, 381. So ionization enthalpy, it is group in decreasing. But how much values are there? That is 500, 400, 400, 400, 300. Okay. Hydrogen belongs to same, no? Hydrogen belongs to same. Yes or no?
yes, sir.
It is having the 1300, around 1300 kilojoule per mole. So what the region can be there? What the region you are going to get here? Ionization energy, see, this is the 1312. But other element you are saying that is the lithium you go, sodium you go, potassium, they are having the 500, range of 500 kilojoule per mole. Please explain the concept behind this. Hello, Sanoy.
Sir,
Are you
I understand.
thinking? Okay, think. Should I explain? Or
Sir, you can explain the next one.
Okay. Then I am telling. See, non-metal.
Sir, I am asking one thing, sir. Should I memorize these values, sir?
No. No need to memorize. No need to memorize. Just you need to logically. They are the logical problems. No, logical. That is somewhere you need to correlate. Why something is high? What is the reason? Why something is less? What is the reason? Because same belongs to the same group. And you only said that is this is placed. Actually, this is placed in the group 1. But the why, if it is placed in the group 1, their range will be that is 500. So that sudden change must not be there. No? It is more than 2 times. Yes or no?
Yes, sir.
So what can be reason? That reason we need to explain. What is the reason? See, non-metal, you see, gain electron. Non-metals gain electron. Hydrogen, what is there? Hydrogen is having the tendency. What tendency? 1 electron if it gain, it will become the H minus. Okay. H minus means the stable helium configuration. Stable. What is there? Helium configuration. Yes or no? So in spite of giving, what it is tendency is there? More tendency to gain the electron and become the stable like helium.
Yes.
But you talk about the lithium. Lithium is having the 3 electron. It is what is 2, 1. So it is having the tendency to lose 1 electron. Okay. And by losing 1 electron, it will have the 2 electron just like the stable helium configuration.
Yes.
Stable helium configuration. So if you talk about the the concept, that is the hydrogen is having the lesser tendency to lose electron. It required more energy to lose electron in compared to other lithium metal or the sodium metal. They are having the one electron extra than the duplet or the octet, so that less amount of energy required to lose electron. But here the non-metal are the electronegative. Non-metal are electronegative, metal are electropositive. So being the electronegative atom, sodium, how much electronegativity is there? En value 2.1. Okay, 2.1. And if you talk about the lithium value, it is 0.000 something, zero less value is there. So here it is more electronegative, means in spite of giving, it takes the electron. So that is why ionization, removing the electron from the hydrogen is difficult. Is it okay?
Yes, sir.
Okay, next one. Electron gain enthalpy, you see, it is minus 76 kilojoule per mole. Okay. It is also compared to the other element, it is high. Can you tell me what can be the reason? If you see the other one, let me tell you. Electron gain enthalpy of group 1. GR group 1. I'm just correlating to you. Let us see if anything you will find. Okay, it will be clear concept. It can have the. See, what are the? This is not the group 1. We have to see the group 1. Is there anyone? No. Group 1. Wait, Sanay, taking little bit time to you. You see the any values are there, electron gain enthalpy. It is there or what? See, hydrogen is how much, Sanoy? Here, see, minus 76. Visible to you?
Yes, sir.
But here you see, the lithium, you see, lithium is how much is there? Minus 60. So, why the electron gain enthalpy of the hydrogen is negative? But lithium, other metal of the transition metal of the same S block element are less. What can be the reason? 76 and they are having the less. The reason is, what is the metals are electropositive. They are having not tendency to accept the electron in spite of the losing electron, right? So since they are having tendency to lose electron, so they are having the lesser electronegativity value compared to the, what is there? Compared to the hydrogen atom. That you need to memorize. Now, the second question is there, covalent radius. Covalent radius, that is the, since it is non-metal, so it has the covalent radius. But if you are going the metal, it is having the ionic radius. Now, the third one, these two questions, covalent radius is 37 and ionic radius is 208. What can be the reason? Please explain. Yeah, Sano. Oh, what happened here?
Yes,
Yeah, Sano, are you telling something?
sir. Covalent is 37, ionic radius is 208.
That is I'm asking, reason.
Sir, ionic radius is having 10.
Ionic means
No,
H
sir.
minus. Ionic means H minus is there here, not H plus. H minus is there.
Yes, fine.
Reason. I just want to know, Sanoy.
Sir, I don't know that.
Not telling. Should I tell?
Yes, sir.
Okay. Okay. Not an issue. See. Anion radii, then atomic radii, atom radii, then cation radii. Okay. Of same atom. We are talking about the same atom, right? So same atom is there, so means proton. Okay, proton. Positive charge will be same. Say this will be same. same, and this is also same. Negative charge. So anion will be more negative charge, more electron, equal to the proton and less electron. So which will have the stronger attraction, nuclear attraction? Means that is here the suppose that is what is happening. If one proton is there, okay, and zero electron, one proton and one electron. Here is one proton and three electron. So which will attract more strongly? In which case attraction will be high?
Sir, 1 second. See, anion. Sir, in anion there should be 2 electron or 3 electron.
No, just it is imaginary question. Let us go 2 electron. Okay, suppose 2 electron. So which will have the more attraction?
Sir, atom radii will have higher attraction.
No, sir, no.
No, sir, anion will have more attraction because it is more negative charge.
Greater the electron, Sanoe, greater the electron, because which one is pulling the electron? Which is pulling the electron is what? Radii is what? The distance between what? Distance between the nucleus and outermost electron. This is what the radii, right? This is the radii. If more electrons are there and less proton, they can't attract strongly, yes or no? If more electron is there, if more electron, less proton. Proton only attracting na, less proton.
Yes.
So less attraction. Yes. So less attraction is there, so large radii. It will be what? Large radii. Yes or no?
Yes.
So large radii. So out of this, you see that is what is the anion radii will be always higher than the atom, and atomic radii will be higher than the cation because cation is having less electron. So here you see covalent radii means this is the radii of the hydrogen atom. This is the radii of hydrogen atom. This is going to be radii. So this is going to be small. But here is H minus. So H minus means there is 2 electrons. So radii will be high.
Yes. Understood.
Understood. Thank you very much for understanding. लीजिए question करिए आप. We are having the Sanoji F minus. Don't take F minus because I need to take the plus also. Cl plus Cl minus, which have the high radii and high Y, which have the high radii and Y. Which have the highest radii and Y. The radii you must have studied now in periodic table. What is the problem you are not telling?
Sir?
This atomic radii, ionic radii you studied in the periodic table chapter.
Sir, I'm writing everything in the copy also. So that is
not a problem. You are writing, that is great only. Just I'm asking you tell the order.
Cl minus will have the largest radius because the number of proton, the number of electron more than the number of proton. Then Cl will come, then Cl plus 1.
Thank you. Order of radii. Okay.
Sir, not the order. Sir, what I think this should not be. So because in the middle Cl should be there, no?
Okay. Sorry. I'm rechanging this one now. The answer I'm changing. Now the answer will be like that. Here the positive charge will be here. This is the answer. Done, na? Preparation and properties of the hydrogen we have already done. Not more than that, not there. That a little bit, if you want more, you can. So here, see the one more point is there. This is called water gas shift reaction. This we study.
Sir, one thing what I just
Carbon dioxide removed by scrubbing with the sodium arsenate solution. Presently, 70% of industrial dihydrogen is produced from the petrochemical. 80% of the coal. Petrochemical means petroleum product. Then 80% from the coal. Okay. 4% from the electrolysis of the aqueous solution, and 1% from the other source. That data are supposed to be memorized. When you will solve the previous year question, then you will be able to understand that which question, what type of the headings, what are types of topics are important. Here they are saying, comment on the reaction of dihydrogen with chlorine, sodium, and copper, second chloride. So chlorine is there is no problem. H2 plus Cl2, it will give the 2HCl. Okay. This one. So dihydrogen reduces chlorine into the chloride ions and itself gets oxidized. H plus ion by chlorine to form the hydrogen chloride. Okay. And the electron pair is shared between the H plus and Cl formation of the covalent molecule. So there is no problem, I think. HCl, this will be the negative charge, this will be the positive charge. Polar covalent bond, polar covalent. If you are talking about the oxidation number, so it is going to be take +1 and this is going to take -1. Okay, so there is no problem. But second one, they are saying sodium. So sodium is going to form the hydride. Yesterday I told you with the metal, it formed the hydride. So
Sir, I
dihydrogen.
was saying that question only. Sir, can we write like this that 2H one thing. This will be one. So here, so this will be 0, this will be 0, so this will be +1, this will be -1, this will be oxidized, and this will be reduced.
The same only now. Same.
No, but you are writing some polar covalent version, delta plus delta.
I explained in the different way. In the different way. Okay. Just I want to. I just want to tell that is this positive charge is not the ionic, na. If any compound is giving positive charge and negative charge on any compound, this is supposed to be the ionic. It seems that is, see here what they said. That is how it is wrongly, almost wrongly they mention. H plus ion by chlorine atom. See there. Dihydrogen reduces chlorine into the chloride ion, Cl minus, it is there. And itself get oxidized into H plus ion by the chlorine to form the hydrogen. It is not the complete H plus. It is not the complete H plus and complete Cl minus. If complete H plus and complete Cl minus is there, so what the compound, what type of compound it will be? It will be the ionic. Yes or no?
Yes.
But what is there? Come down here, you see, an electron pair shared between the hydrogen and chlorine, leading to the formation of covalent molecule. So what is there? Covalent molecule means it is the what type of covalent? Polar covalent bond. That is why partial positive, partial negative are coming. That I want to tell. No.
Yes, sir.
Okay. Second one with the sodium. So sodium, it is forming the ionic hydride. Dihydrogen reduced by the sodium to form NaH, and electron is transferred from the sodium to hydrogen, leading to the formation of ionic compound. Is there any problem? Sodium, you know, configuration sodium is the 11. So that is 281. One electron is star. And hydrogen, you see, that is one electron less than the duplet. It is the less than the duplet. It is the what? More than the octet. So what is going to do? Sodium is going to transfer one electron to which one? Chlorine atom. So this is forming Na plus and Cl minus. So this compound they mention. Okay. This is the important one. Next one. Dihydrogen. Dihydrogen reduces copper second oxide to the copper in the zero oxidation state and itself get oxidized to water, which is covalent. So this is the oxidizing action, reducing action, how it is it is doing. So we are having the H2 and we are having copper second oxide CuO. So here is the +2 oxidation state. So after the reaction, it is going to form the H2O and this will be Cu0. So this is what is here is 0, here is the +1. So hydrogen itself oxidized, but copper itself what is happening? Reducing. No.
Yes.
Okay. Usage of dihydrogen. See the important usage are there. What are the usage are there that you? The first most important one in the manufacturing of the ammonia. Once you prepare the ammonia, you can prepare the nitric acid, nitrous acid, and nitrogen fertilizer. That is also urea, ammonium phosphate. They all are prepared from the ammonia only. So urea formula is what is there? NH2, C double bond O, and this is NH2. NH2, C double bond O, NH2. This is what urea. How it is preparing? We are preparing from the ammonia. So far most important of the hydrogen is it is used in the preparation of urea. Second one, they are saying in the preparation of Vanaspati ghee. Vanaspati ghee, suppose oil is there, na, this one, CH2. Okay, this is the oil are there. Okay, unsaturated. Now you add the H2 in presence of NiPT. So it will give the saturated alkane. And saturated alkane or what? Ghee. This is the 10th standard. Do you remember this one?
So this one is the reduction reaction.
No, but it is there in the 10th reaction. Na? This is the hydrogenation.
So 10th only I'm talking about. So there was in the hydrocarbon, so there was one reduction reaction.
So conversion of see what they are saying. Vanaspati fat by the hydrogenation. What is there? We use the hydrogen. So this is also important. They can ask that is which gas is used for the conversion of the Vanaspati oil to Vanaspati ghee. So Vanaspati fat, how we will convert by the hydrogen gas. Next one is there. This is also quite important. Manufacture of the bulk organic chemical methanol. Methanol we can prepare with the carbon monoxide and you are passing the dihydrogen. It will give the methanol, right? So this methanol is what is spirit. In the lab, it may be using in your lab. It is the spirit. Okay, very poisonous one. So this is used in the as a fuel in the laboratory. Have you seen the burner in your lab? Burner.
Sir,
What the,
we have not had. Yes, I've seen, but sir, that burner is running on LPG.
Acha, LPG. Earlier time it was running in our school. It is the what is there in
Sir,
our
I
school?
saw in our school that was there in 10th you showed in practical
So
class.
that is what the spirit lab. Na CH3OH is there. This is CH3OH. Next one is it is widely used in the manufacture of hydride. Hydride means like that it can lithium aluminum hydride. Have you heard about that? LiAlH4, NaBH4, okay, NaH, okay. These are the hydrides used for the reducing agent, okay. Used for reducing agent. Used for what we are using? Used for reducing agent. Used for reducing agent. So this is used for the that I will tell you detail. The hydrides are there. It is used for preparation of the hydrogen chloride, a highly useful chemical. So that you know very well. H2 plus Cl2, it will giving 2HCl. So there is no problem. This is not going to come in exam, but this first and second, third they can come. Next one you see. In metallurgical process, it is used to reduce the heavy metal oxide to metal. So it is used for the reduction. Suppose heavy metal, this is PbO is there. Generally, we will reduce with the what carbon, but you can reduce with the hydrogen also. This is the Pb plus H2O. So heavy metal oxide can be reduced by the hydrogen. Atomic hydrogen, oxyhydrogen, torches find use of the cutting and welding purposes. See, this is the atomic hydrogen. H atom is there. Atom. So in atomic form, it is most reactive. In atomic form, it is highly reactive. It is highly reactive. Any element in the atomic form highly reactive. Okay, in atomic form. So what they are saying, in atomic form, it is used for cutting. How can you use for cutting and welding? Can you tell me?
So they are heat by the combustion of that one.
Since it is very unstable, so they provide huge amount of energy. That is what used for cutting. Atomic hydrogen atom produces a produced by the dissociation of dihydrogen with the help of electrical allowed to recombine on the surface to welders to generate the temperature. How much? 4000 Kelvin. How much temperature it is generating? 4000 Kelvin, right? Are
Yes.
you getting? Second, it is used telling something,
Yes.
asking something.
No, sir, I have understood everything.
Okay, thank you. Here you see, it is used as a rocket fuel in the space research. So whatever the that one what the we are sending now on the moon, Chandrayaan, this all they are having the different type of their that is the they are, suppose this rocket is there, na rocket. Suppose this is the rocket. There. Okay, so what is the some portion they are filling with the hydrogen, some portion they are other. So all different portion are filled by the different what called different the substances, fuels and propellant. So this is the in some portion they fill the hydrogen also. Now next one, dihydrogen is used in the fuel cell for the generating electricity. It has many hydrogen fuel cell is there. Hydrogen fuel cell. Hydrogen fuel cell. Have you heard about this one? Fuel cell.
Yes, sir. In some vehicles they are using this one.
Hydrogen fuel cell, it is being used nowadays. It has many advantages over the conventional fossil fuel electric power. So whatever in NTPC is producing by fossil power, that is coal, it is relating the too much of the energy. But here the hydrogen fuel, it does not produce any pollution and release greater energy per unit mass of the fuel in comparison to gasoline and other fuel. So that you must understand. Here is the hydrides. So hydride, if you see, Sanoy, these are the hydrides, means what? They are reacting with the metal to form the hydride. But how many types hydride they are finding? Ionic, saline, or